Hello, welcome to the video. Today I'll be explaining how quicksort is performed with the help of an example. So let's take this array as an example. In quicksort, first of all an element is chosen and this element is usually termed as the pivot element. You may choose any strategy to select this element. It may be the first element or it may be the last element, the middle element or any random element. In this example, I am considering the first element as the pivot element. Once the pivot element is chosen, the next process is to take the pivot element to the correct position in the final sorted array. And by the end of this procedure, all the elements to the left of the pivot element will be less than the pivot element and all the elements to the right of the pivot element will be greater than the pivot element. So let's see how this is possible. Here in this example, we take 50 as the pivot element initially. Now to take 50 to the correct position in the array, we take two more variables I and j. I contains the index of the element immediately next to the pivot element and j contains the index of the last element of the array. Now I moves rightward until an element that is greater than the pivot is found and j moves leftwards until an element that is less than or equal to the pivot is found. So here, since 30 is less than 50, I moves to the right, and then since 80 is greater than 50, I stops moving rightwards. Now, since 70 is greater than 50, j moves to the left, and since 20 is less than 50, j stops moving to the left. When I and j stop moving, the elements at these positions are swapped. Now again, since 20 is less than 50, I moves one place to the right, and again since 10 is less than 50, I again keeps moving to the right. I stops moving on reaching 60, and now since 80 is greater than 50, j moves to the left, and since 60 is also greater than 50, j again moves to the left and stops moving when j reaches 40. Now at this point we can see that the index value in j is less than the index value in I. When this happens, the pivot element is swapped with the element at j. Now 50 has reached the correct position in the final sorted array and hence hereafter the position of 50 will remain unaltered. And also the array gets partitioned into two parts. The elements to the left of 50 is considered as one partition and the elements to the right of 50 is considered as another partition. So the quicksort procedure has to be applied separately to each of these partitions. Now due to this reason, the approach that is used in quicksort is termed as divide and conquer approach. So first let's apply quicksort to the partition on the left. So here 40 will be chosen as the pivot element and assign the variables I and j as before. Now I moves rightward to find an element which is greater than 40, but the subarray ends before finding such an element and hence I stops at 10. And since 10 is less than 40, j remains at the same position. Now again we have reached the state where I is not less than j, and this is the time to swap the pivot element with the element at j. And hence 40 has also reached the correct position in the final sorted array. Since there are no elements to the right of 40, there is only one partition which is formed by shifting 40. Now again choose 10 as the pivot element. I points to 30 and j points to 20. Now since I is already pointing to an element which is greater than 10, it doesn't move to the right. J moves leftwards in search of an element which is less than or equal to 10 and it stops on reaching 10. Now since I is not less than j, the pivot element and the element at j are swapped and hence 10 remains at the same position. Now, since there are no elements to the left of 10, there is only one partition formed. To sort this partition, 30 is taken as the pivot element and I and j point to 20. Now 20 is less than 30, but since there are no more elements in the array, I remains at the same position. And since 20 is less than 30, j also remains at the same position. Since I is not less than j, the pivot element and the element at j are swapped. This results in a partition with a single element. Hence, there is no need to apply quicksort to this partition. Now let's apply quicksort to the initially formed right partition. 60 is taken as the pivot element. I points to 80 and j points to 70. Since I is already pointing to an element which is greater than 60, I remains at the same position. J moves leftwards in search of an element which is less than or equal to the pivot and stops at 60. Now again, since I is not less than j, the pivot element and the element at j are swapped and hence 60 remains at the same position. Now the final partition, which consists of 80 and 70, will also be sorted using quicksort, as a result of which 70 and 80 will get swapped. And with this, the array gets completely sorted. Thank you for listening to me. Stay tuned for the algorithm and the remainder of the sorting algorithms.